Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16F4 indicates a low voltage condition in the starter cut relay 2 control circuit of a Honda HR-V models from 2016 to 2022. This specific code suggests that there may be an issue with the electrical communication or functionality of the relay that prevents the car from starting. The starter cut relay itself is a critical component in the ignition system, acting to prevent the engine from starting under certain conditions, thus ensuring safety and preventing damage. If this relay is malfunctioning, it could either fail to engage or possibly allow an unintended start, which poses a risk. This situation typically requires a systematic troubleshooting process to identify the root cause, which can range from simple wiring issues to the need for replacing the powertrain control module, PCM. Understanding the role of each component involved and following precise troubleshooting steps is crucial for efficient and effective diagnosis and repair. The DTC P16F4 specifically points to a problem with the starter cut relay 2. This relay plays a vital role in controlling the power supply to the starter motor, thereby influencing whether the engine can start. When the ignition is turned on, the relay engages, allowing electrical current to flow to the starter system. The starter cut relay 2 is typically located in the underhood fuse and relay box. Its faults could lead to a low voltage condition being detected by the powertrain control module, PCM. An issue in this relay's function can prevent engines from starting, causing frustration for the vehicle operator. Being aware of the relay's function is essential for understanding the potential implications of this diagnostic code. There are several possible causes for the appearance of DTC P16F4 in a Honda HR-V. One common issue is wiring failures, such as shorts, opens, or poor connections, especially between the PCM and the starter cut relay. Such wiring issues can create a low voltage signal that prompts the diagnostic trouble code. Another cause could be a faulty starter cut relay itself, which may be unable to function correctly, leading to a failure in engaging the starting system. Lastly, the problem could lie within the powertrain control module, PCM, particularly if it has outdated software or is faulty. Diagnosing these potential causes accurately is critical to determining the required repairs and ensuring a successful fix. The primary symptom associated with DTC P16F4 is the engine failing to start. This is often coupled with a warning light or error indication on the Honda Diagnostic System, HDS, when the vehicle is scanned. Additionally, you may notice poor electrical connections, which can further exacerbate the starting issue. These symptoms not only point to a possible malfunction in the starter cut relay, but also may indicate underlying issues with the vehicle's electrical system. Understanding these symptoms is important for effective troubleshooting, helping technicians focus on the most likely areas for the cause of the trouble code. The first step in the troubleshooting process for DTC P16F4 is to attempt to start the engine. This simple action is critical because it allows you to confirm whether or not the engine is able to start under the current conditions. If the engine starts successfully, this suggests that the issue may not be constant and that it can potentially be replicated. If the engine does not start, it indicates that further investigation is necessary. Based on this step's outcome, you will move on to the next steps, whether it entails checking the vehicle's mode or assessing additional malfunctions with either the starter cut relay or related systems. In the second troubleshooting step for DTC P16F4, it is essential to switch the vehicle to the off lock mode. Afterwards, the ignition should be turned back to the on mode while keeping the engine off. The next crucial action is to clear the DTC with the Honda Diagnostic System, HDS. Once the DTC has been cleared, it's important to check for any pending or confirmed DTCs using the HDS functionality. If DTC P16F4 is still detected, this confirms that the fault continues to persist, warranting further inspection of the starter cut relay and possibly the wiring to this component. Conversely, if no DTCs are present, it might suggest that the fault is intermittent or transient at this time. The third troubleshooting step involves checking for a short in the starter cut relay 2 control line. To do this, the vehicle must be turned off completely, and then the SCS line needs to be jumped with the HDS. Once this is achieved, you'll need to disconnect the PCM connector A, 51P. Following this, remove the starter cut relay 2 from the under-hood fuse and relay box for further examination. It is crucial to measure the resistance between specific test points to determine if there's a short or fault in the wiring. Established standards require that resistance is at least 1.0 megaohm. Ensuring that the wiring is intact is vital, as any shorted wire could lead directly to the low voltage condition identified in DTC P16F4. In the fourth troubleshooting step, you will focus on verifying the starter system functions properly. Begin by ensuring that the vehicle is in the on mode, and if your Honda uses a continuously variable transmission, CVT, make sure it's in either P or N position. For manual transmission, MT vehicles, shift the lever to neutral and press the clutch pedal. The next step is to attempt starting the engine while checking various parameters using the HDS. Specifically, ensure that the starter cut control return on conditions match the expected threshold parameters. If everything aligns, proceed to the next step. If discrepancies exist, you may need to address symptoms linked to the engine not starting. The fifth troubleshooting step focuses on identifying potential failure areas linked to DTC P16F4. As usual, begin by turning the vehicle off and jump the SCS line again with the HDS. Then, disconnect the PCM connector A, 51P, to isolate the issue. After making these disconnections, activate the vehicle into the on mode. Once again, verify the transmission's positioning, either in P or N for CVT or neutral for MT. After this, you will measure the voltage between specific test points to assess if the voltage is registering battery levels. This confirmed voltage indicates proper functioning. If the battery voltage is not present, further diagnostics will be necessary to determine if the fault resides in the PCM or elsewhere in the circuitry. In the sixth troubleshooting step, you will perform an open wire check for the ST-cut RLY2 CL line. To initiate this, turn the vehicle to the off lock mode and remove the starter cut relay 2 from under the hood. Next, check for electrical continuity between designated test points while ensuring the relevant components are disconnected. Confirming continuity is essential, as this checks for intact wiring between the PCM and the starter cut relay. If there's continuity, it suggests that the wire is functioning as intended, thus allowing you to proceed. However, should continuity fail, it indicates an open circuit that will require immediate repair of any breaks in the wiring to rectify the issue and restore proper function. The seventh step in the troubleshooting process involves checking the fuse designated as number C26, which is a 7.5 ampere-hour fuse located within the under-dash fuse relay box. Fuses are critical components that protect circuits from overload and short circuits, and a blown fuse can directly cause electrical failures like the one represented by DTC P16F4. If the fuse is intact, it allows you to proceed with further checks. If it is blown, you will need to explore and confirm the integrity of the wiring for shorts between the fuse and the starter cut relay. Ensuring the fuse is functioning properly is essential to maintain the complete circuit and facilitate the operation of the starting system. In the final troubleshooting step related to DTC P16F4, you will perform an open wire check for the IG1 ST cut RLY line. This necessitates disconnecting the under-dash fuse relay box connector Q40P. Upon disconnecting, you should connect certain terminals with a jumper wire for testing continuity. Check if there is continuity between designated test points while ensuring that all other connections remain disconnected. If continuity is confirmed, this indicates that the IG1 ST cut RLY wire structure is adequate, facilitating electrical flow correctly. Conversely, if there's no continuity, it suggests there is an open circuit requiring repair, which can be critical for restoring functionality to the starter system. After completing the necessary repairs based on the troubleshooting steps outlined for DTC P16F4, it is crucial to perform a final verification to ensure all issues have been resolved. Begin by clearing any pending DTCs using the HDS, which previously indicated the low voltage condition in the starter cut relay 2 control circuit. Once cleared, attempt to start the engine again under the same conditions as when the original DTC appeared. Monitor the system for previously indicated symptoms to confirm functionality. If no DTCs reappear and the engine starts consistently, the repair is validated. This reaffirmation is essential to guarantee that the root cause was addressed, restoring the vehicle's operational capability efficiently. To prevent the recurrence of DTC P16F4 in Honda HR-V vehicles, establishing a regimen of preventive maintenance is key. Regular checks of the electrical system, including connections and wiring, can catch potential issues before they escalate. Through routine inspections, technicians can identify frayed wires, loose connectors, or signs of corrosion that may lead to low voltage conditions. Additionally, ensuring that the starter cut relay and PCM are updated with the latest software can help prevent faults attributed to outdated programming. Documenting these checks can lead to better overall vehicle reliability. Preventive measures also promote longevity within the electrical systems, which are critical for the vehicle's safe operation. In summary, addressing DTC P16F4 involves a systematic approach to troubleshooting that emphasizes the importance of each component within the starter cut relay control circuit. Following the detailed steps allows technicians to accurately diagnose whether issues arise from faulty wiring, the starter cut relay itself, or the powertrain control module. Once the underlying problems are detected and repaired, testing ensures that the issues have been completely resolved. Emphasizing preventive maintenance can significantly reduce the likelihood of similar faults emerging in the future. By cultivating an understanding of electrical systems in Honda HR-V vehicles, owners and technicians can maintain operational integrity and maximize the vehicle's performance over time. Please like and subscribe to the channel. See you next time.